Welcome to today's webinar. The topic today is geotechnical analysis with construction stages in RFEM 6. My name is Andreas Hörold. I'm responsible for marketing and public relations. For instance, the content of the Dlubal website, the German and English webinars, newsletters, customer projects, and so on. I will be the moderator today, and I will answer your questions together with Alexander Meyerhofer. The presentation will be done by Juliane Stopper-Aktak. She's responsible for product engineering and customer support, and she's mainly responsible for the geotechnical analysis add-on. Alexander is the head of product engineering of the concrete and geotechnical analysis add-ons, and also for the customer support. And as I said, he will support us by answering your questions. Okay, then I switch off my webcam that you can see the full screen. You can ask questions when you click on that question mark above. Then you can enter your question in that field, press send, and we will receive your question, and then we will answer you. Okay, that should be all from my side. I hand over to Juliane. Juliane, it's your turn.
Okay, then thank you very much, Andreas, for the introduction. I will take over and show you the next slide, which contains the agenda for the webinar for today. We will, in a first step, have a look at the soil material, at the hardening soil model, and define the input for the material. After that, we will generate the soil solid. We will finish the structure and topology of our model. And in the third step, we will have a look at the loads. We will define construction stages and care about the combinatorics. Then we are at the point where we could solve the model. And in the fourth point, we will have a look at the results. We will have a look at settlements and soil stresses. And with that point, we will finish the main part of the webinar. In the fifth point, we will have a short look on a triaxial test. To show you how it could be used for the calibration of soil material input parameters. And then finally we will have a short look on prospects for the geotechnical analysis add-on. Okay, before we go to the program, we will have a look on the hardening soil model and the main aspects that it is able to consider, the main aspects of soil behavior. Okay, the soil shows a strong stress level dependency of its stiffness. We can see here in these images how the hardening soil model considers this. We can see on the left side the stress-strain response for oedometric conditions, and on the right side the stress-strain response for triaxial conditions. And we see that for each with change of stress level, the slope changes and therefore the soil stiffnesses. And you also have here the equation in both graphics, which shows how this stress level dependency is considered. We have from a geotechnical report, you have a reference value for the stiffness, and this is received for tested for a related stress level. It is the P reference, and you have the reference value of the stiffness. And you have also for your material these cohesion and friction angle, and you have this exponent which controls the stress level dependency and receives or contains values between 0.5 and 1 depending on the soil material you have. So you can see that with this equation, for different stresses, you can calculate the related stiffness. Yeah. Okay. Then the soil stiffness shows a load path dependency. It means that the soil shows different behavior for primary loading compared to unloading and reloading. And we can see here in this graphic for the triaxial conditions, the hardening soil model, how it behaves. We have elastoplastic behavior in primary loading, and we have for unloading and reloading linear elastic behavior. Yeah, then we can go to the next slide, which is about the yield surfaces. Soil, the hardening soil model is an elastoplastic model with hardening, and it shows plastic strains before reaching failure. It has these two yield surfaces. The one is this cap here, and the other one is the, let's say, like a pyramid shape surface. And this means that the plastic deformation consists of two components. We have shear plastic deformations and volumetric plastic deformations. The hardening soil model shows isotropic double hardening, and it uses the Mohr-Coulomb failure criterion. Okay, yeah, that's it so far for some backgrounds and some introductory information. Now we will go to the program and define the input values that are needed for the hardening soil model. Okay, so this is RFEM 6, and you can see that I have a building prepared, as this webinar shall have the focus on the soil and the construction stages. So let's go to the materials. I go to the dialog where we can define the materials. We have already in that model the concrete and the reinforcement steel, and we have 3 different soils, and I would like to define with you a fourth fourth soil material. Therefore, I click here and I can create a new material, and we can see that we have here the material type, and here it is needed to select the soil. And when you have the soil selected, then you have here the specific soil material models of RFEM 6 that are provided, and we today want to use the hardening soil model. Okay, with the selection of that material model, we can here on that basic properties define the specific weight of the soil, and we have here the drained value, which shall be 18.5 kilonewton per meter cubic and 20.5 for saturated situation. And we can give it a name. It will be the sand layer S2. Okay, then we can go to this specific register where we can give the input values for the hardening soil model. Here we have the strength parameters, and we will give 1 kilonewton per meter square for the cohesive strength. We have an internal friction angle of 35 degrees and the angle of dilation of 5 degrees. Yes, and here we can enter the reference stress for the stiffness, as we saw in that equation. And here we have the exponent. As we have sand, we use here 0.5 for m. Okay, then for this layer we have an oedometric stiffness modulus of 58 meganewton per meter square. We have this shear hardening parameter, which shall be 0.6 promille, and we have this stiffness for unloading and reloading, which shall be 174 meganewton per meter square, and the Poisson's ratio of 0.2. Okay, and we have the pre-overburden pressure, which we will consider as 5 kilonewton per meter square in that example. Okay, then that's it. We say okay, and I have my new material here in my list. Then we have here in that folder for basic objects, further objects. They belong to the building. They are prepared. We can go directly to special objects, where we find for geotechnical analysis add-on the boreholes. So we go here and we say we want to create a new borehole. That borehole allows you to directly give the input that you receive from your geotechnical report. At some locations you will have boreholes and information about the material that was found there. So what you define is the location. In our example we will consider only one today, and we will keep the 0.0. Then you can here define the groundwater level. We have 3.9 meter into the depth where the groundwater was found. And in this table you can define the soil layers. We start from ground level surface and go into the depth. We have at first kind of filling material, then we have sand as one, and then we have some mergel layer, and we have a sand S2. Okay, then we need to define the thickness of the layer. We have 4 meters 80 for the first layer. We have 3 meter 50 for the second, and 4 meters for the third, and 3 meters for the mergel, and 15 meters for the sand S2. Yeah, this is the borehole, how it was found, and we can say okay, and then we have it in our model. The next special object for geotechnical analysis is the soil massif. We will define a new soil massif, and this soil massif shall generate the soil solids from the borehole. So I can assign my borehole, and as I have only one, I can directly enter the number of the borehole here. Then we have to define the location, the center of the soil massif, where it is placed. In this example, it shall be placed at 6 meter in X direction and 8 meter in Y direction. And we have a soil massif size of 48 meter and 48 meter in the second direction. The Z coordinate is taken from the boreholes. It is possible to edit this if you see from first results that a massif of less height is needed, then you can reduce it also. We will now keep this default setting. Here in options you can activate the groundwater level. We want the groundwater to be considered. So now I can say okay, I filled all the information that was needed, and my soil massif, my soil solids are generated. We can see them here now in the basic objects. We have here the soil solids that are generated. For each layer we have one soil solid, and we also have here in the surfaces the groundwater surface. And what we have too is the supports. I go to Navigator Display for activate them in the display, and we go to transparent model, then we can see it better. We have the supports, they are generated too, and we can find them also here in types for surfaces. Here we have surface supports, and we can see that we have these supports at the vertical surfaces, and we have a fixed support at the bottom. Okay, I will again switch them off in the display, as I don't need to see them all of the time. Okay, so this is prepared, our soil is prepared. I would like to use another special object, therefore we go to that folder. I want to use surface contacts for the contact between the building and the soil top surface. Okay, therefore I create a new surface contact, and we go to the slab and select the slab, and we select as second surface this surface of the top of the solid. I say OK, and we have a surface contact type assigned. We have failure under tension. I want this to be considered. We say OK, and now we have our surface contact in the model. We create another one for this foundation slab here, and we again select the top surface of the solid, and I say OK, and I have the surface contact here too. Okay, here we can see it. So that's it. The structure is prepared. What we can now do is we can generate the mesh. I would like to show you that we have here in Calculate, we have mesh settings, and we have a general setting for the target length for the finite elements, and we have in solids a special checkbox and option to define a target length for the soil solids, as the soil needs larger element sizes than the building. So we have it here. I say OK, and what I want to do is I want to assign to that surface a mesh refinement. Therefore I can select the surface and can go on Edit, and here in the options we have the mesh refinement. So I activate it, and I want to have 1 meter element size for this top surface. Say OK, and now it is considered, and I want to use also for this solid here, for the top layer, I want to use another mesh refinement. I do activate it in the solid, again in options. I want to use the layered mesh. Therefore I have to select the first surface from where it shall start. I take this top surface, and it automatically finds the surface on the opposite side of that first surface, and I want to have 5 layers of elements. I say OK, and then we can generate our mesh for this model. Okay, we will go to the solid model display, and we have our mesh prepared. There is one more thing I would like to do. I switch off the display of the mesh. I would like to use object selections, as it is quite useful in the definition of the construction stages. So we go into that Z view, and I select these boundary surfaces. I will later need them, so I want to define an object selection for them. I also do select this bottom surface. Now I can do the right click and say create object selections, and I give it a name. I call it boundary surfaces. Boundary surfaces solid. Okay, and then I have my my object selection prepared. Okay. Then we have this. We can go on with the loads. We will have a look at the loads we have here. The self-weight in the model. We have also the self-weight for solid. For this self-weight for solid, we have an own action category called permanent soil. If this action category is selected, we have the self-weight active only for soil solids. If we have the action category permanent, then we have the self-weight active for everything except the soil solids. Then we have some further dead load and we have a live load in this model. Okay, here we can see the actions and that are part of this model, and we have design situations, and here we have construction stages. And now we will work about the construction stages. We will define them. I will therefore leave this dialog. For construction stages, it is needed to define always the structure of that is part of that each construction stage, and also the load. And we will start with the structure part. So I go here and say new construction stage, and we start with the CS1. And now we have to activate the components or the objects that shall be changed for this stage. So what is changed is we will assign the solids. We can activate all of them, and now we see they are active in that stage. And what we do need too is the surfaces that have the boundary conditions, the boundary supports or the surface supports assigned. Therefore I also activate surfaces here, and now we have to add them, and therefore I can use my object selection. I will go here on guide objects and have a click on the boundary surfaces, and you can see it's filled in here. We can say OK, and we have our boundary surfaces assigned. Okay, then we can come to the next construction stage. In this stage I don't want the structure to be changed, therefore I remove the check in these boxes, and we create a new construction stage. And here we can assign surfaces. We can assign the slab. I did prepare an object selection for this, as we can see here. Now these surfaces are assigned. Then I also need to assign here the surface contacts. Here again I can say all, as they all shall be considered for that stage. Then we can define the next stage. In that stage we will assign the walls of the first floor. So I go here and we have them. I have it prepared in that model, and we will have the members, the columns of that floor. They are also in that object selection. It automatically takes the members from there. We can say apply and create a next construction stage. Here we will assign the surface here and its ribs. I will say OK, and I have it assigned. Then we come to the second floor. We again have here columns, and we have surfaces, the walls, and then we can come to the top floor where we have the roof and the ribs. We can select it, and it will be the last input from structure side for the construction stages. Okay, and I can say OK, and I have my construction stages defined. These are the stages, and we can also look at the graphics. where we can see what is contained. If we select here the first stage, we can see that we only did assign soil solids and the boundary surfaces. And in the next stage it's the same, and in the third stage we can see how the building is start to be built, and yeah, up to then. Okay, then now we can give the load for the construction stages. So we go back to the load dialog, and we have here in the register construction stages where we can define the loads. We start with the first construction stage. We have as load case the self-weight for soil. So we do add it here, and it is a permanent load. So in all of the further construction stages, it is considered. Then we can go to the main window again. In the analysis with the hardening soil material model, it is needed to have in the first stage the and kind of initial stage where we give the material linearized, and therefore we define a structure modification. We create a new one, and here we want to have the material nonlinearity deactivated. So I will give the modification a name so that we have an overview more easy. I will say material linearized. We say OK, and now we can see that for this stage we will linearize the material, and we will have a short look to the static analysis settings for this stage. We go here, and we can see that we have one load increment, which is fine for the linearized material, and we keep the settings. We say OK. Then we go to the next stage, and in this stage we didn't change the structure. In this stage the material will be activated. The hardening soil model will not be linearized anymore. We will not assign a structure modification here. Here it will be activated. So I don't need to change the load cases. I will go to the static analysis settings with you. I want to create a copy of my first settings. I will again use only one load increment, but I want to use another option. I want the equilibrium to be solved for undeformed structure. This means in this analysis the deformations will be kept 0, so I will change the name a bit so that I can see it more easy. We will have a look on this later in the results. And we do this because what we need is we need the stresses from soil self-weight, as we need the correct stress state to be known, so that the material model gives the right stiffnesses. And this is what we need. We need the stresses in the elements. What we don't need is the deformations. We don't want to have in our results for deformations the deformation from this soil self-weight state, let's say, stage. Yeah, therefore we set the deformations to 0, but I will show this in the results later. Okay, now we have a next stage. Here we start to put the structure on the soil, and therefore I will now have to assign the self-weight for structure also. It's again a permanent load, so it will be used for the further stages as well. And we will create a new static analysis settings. I will copy the first one, and we will take here a higher number of load increments. I will select here the 4, and yeah, I will change the name so that we can see it more easy. Okay, and we will edit this for all of them. They will get these static analysis settings now. Okay, then I want to create 2 more construction stages in here. I can say create new object. We need them for assigning the further loads. So in this stage I want to assign the the dead load, and I will create another stage where I want to assign the live load also. And for these stages where load is assigned, we need a higher number of load increments. This you will develop with working with the material and your model, how much load increments you need. We here will assign 10 for these both stages. And I want to change the name, so for the overview we have it here. Okay. Yeah, then here we have everything prepared. We have our stages defined. Now we can do a first generation of load combinations for these stages. We have here construction stages. In these stages, the loads are assigned with factor 1, no other safety factor. So later for load combinations, you will have the safety factors considered, and therefore we have to generate the load combinations too. For doing this, we go to design situations, and I today only want to have for quasi-permanent situation the load combinations generated. I can go here to combination wizard and select a static analysis setting. And what I want to do is I want to consider an initial state, and we for now assign the construction stages. We can use it for now. I say okay, and I have some combinations here generated. Then this is fine for me. We will have a look at this later. Okay, you see here that you have for the construction stages the load combinations, and here you see that the loads are combined in the same way, but with the stage the structure changes. Okay, but that's it for now. We have the loads, the stages, and the combinatorics ready. Okay, then I think we are at the point where we could solve the model. You can start to calculate. If you go here on calculate, you can click on calculate all, or you can go on to calculate, and here you can select what you want to calculate. I want to show you another option. We also do provide the option to calculate in the cloud. You can get credits from our company, and then you can here say calculate in cloud. Then your model is sent to the cloud. You will receive an email, and when it is finished the calculation, you get an email back and can download your model with results, and in the same time you can go on working on your computer parallel now. So this is another option, cloud calculation. Okay, I have a model prepared with for that the results are ready, which is solved, and we will have a look at this now. Okay, we have here at first a view on the deformations. Maybe I can go here to the load combinations. That's as I didn't show them in detail at first. We have here the load combinations, and for each combination it is needed to have defined which construction stage shall be considered. So we can see also it is written here in the name for which construction stage this load combination is calculated, and you have an initial state. And here in that initial state, for this example, we have the previous combination assigned. So this one uses this combination as initial state. It starts from there and has more load assigned. And here the construction stages are defined, which need to be considered, as I said. Okay, so now we can look at the results. We have here the deformations, and this is the deformation of the construction stage, where we have no special no factors assigned. We can also go to the combination. We will go to the last combination, so which is the final result for quasi-permanent situation. And we have here the option to check the results of the load increments. So we have to have a look at the last load increment, and then we can see the final result of the maximum deformation, or we can see the deformations for this final load combination with these increments. And we can also switch it off if we don't want to see the results for each load increment. And here we can check the type of results. Now we see the final results. What you can also check is the difference to the initial state. As we remember, the initial state was the previous combination. So what is changing is now that the live load is assigned in this stage. So if we look the difference to the initial state, we can see the component of the displacement or the deformation that comes from the live load assignment. So here you can see differences to the initial state, and here you can see the final results. What I can show too is the first construction stage. Here we have the soil solids self-weight only, and as we can see, it's now the first stage where the materials was considered linearized, and we have here a deformation in that stage. And this is what we don't want to have in the final results, and this is why in the second stage, where also the non-linearity of the hardening soil model is considered, that we used in this stage also the reset of the displacements. So we have now here the displacement set to 0, and now when the building starts to be built, the deformations contain only the deformations that come from that structure, the placement of the structure. Yeah, and we can see for each stage, for each construction stage, how the deformation grows and how it behaves in the soil. Okay. Yeah, then I will go to the last one again. We have another guide object. Can also see here the building. We have another guide object I want to show you. It's here. We have the clipping planes, and we can use them to have a look into the solid. We can create a new clipping plane. We have to select an origin point. Therefore, I activate the nodes in my display navigator, and I select this column here. And we want to see the exact plane, and we can set it to active. And now we see we can look into the inside of the soil, and we can move this plane by having a click on this balls here at the corners, and just move them. And we can also edit this clipping plane by a right click on that ball and say edit. And now we can check the YZ plane, again say active, and go into this direction and check the behavior, get an overview. Okay, then we can go back to the results. This is the deformations. we can also have a look at the deformations in the building. We have here the control panel on the right side, and here you can select for which objects you want to see results. And I had the surfaces switched off, and now I can activate them, and I also see displacements in the building and the surfaces. I want to deactivate the nodes again. And yeah, here we have the surfaces, and what we can do also now, we can now also use the object selections. We can say I want to now see the results only for the foundation slab, which was this object selection, and I can say that I don't want solid results now. And then I have the results for my foundation surfaces. Now we can also switch off the clipping plane. I do a right click here, just deactivate it, and I can see everything again. So this is my foundation elements deformations. Yeah, and that's it. What we can do also is we can create a printout report. We have it here in our navigator at the bottom. We can say we want to have a new printout report, and I want to now deactivate all and just go through it with you and activate the things that are special for geotechnical analysis and construction stages. So we have here in the materials, we have our hardening soil material. When you activate this, you will have all the input values that you defined in the printout report too. Then we did use the special objects. We have here the boreholes and the soil massif. And if you open the drop-down menu of the boreholes, you can also activate that you want to see the layers in your printout report. And we have here surface contacts. And yeah, that's it. We can also select the surface supports as they show us the supports of the soil solid. The surface contact type we can activate, and here we have construction stages, and we can say we want to see information about members, surfaces, solids, and surface contacts as we use them. And of course we have here construction stages from load side. We can also print the static analysis settings. Yeah, and we can also print graphics. Then we can go on save and show, and our printout report will be generated. I did prepare it, so I didn't create a new one now, but just this as information for you. Then, yeah, when you have these results here, you can also print it. We can go on File and say Print to Printout Report. Here you can do some settings for the way it shall be printed. You get this preview, and you can, for example, I don't want to have full height for this build. For this picture, I'll do 50%, and I don't want to see this panel here, so I can remove this one. I can let the graphic be activated and check whether this is fine for me, and I like it, so I can say save and show, and it will be print to the printout report. Okay, then we go on. Yeah, maybe I can show something more. It is now printed. It's a bit short moment. Oh, it's a bit slow. Yeah, as it opens the printout report, that's why. So, okay. now the printout report is open and we can later have a look at it. I want to go back here to see also the solids, and yeah, we can keep it like this maybe. I want to show you the result section. You can also define a result section for the results. We can go here. I want to activate the nodes again, and we can start to set a new result section. Therefore, we have to select the points through which the section shall go, and I use this one and this one as it contains the leading results. And yeah, I can here say which elements I want to see in my result section, and I don't want to see solids. And here I want to again see the results in my foundation slab and the column footings. Therefore I can use the guide objects again and use my object selection. I again go here on these elements and I have them considered, and I will receive results only for them. So I can say OK. And now I can activate the results section, maybe switch off the other things, and now I can see here the result section for these foundation elements and for this footing. Yeah, and I can have a look at this in detail. If I do a right click on my result section, I can see the result diagram. And here we have detailed information along this result section. I can deactivate this. Yeah, we can use this. Okay, and now we can see, for example, I did activate now the surface deformations, the local deformations, and we have here, this is the footing surface till the center of the footing, and this is the slab. And here we can see in detail how along this result section the deformation is changing in the slab. Yeah, and this also could be printout report. You could check other results in detail for result section. Okay, then we can close this. We saw this. Now we will have a look at stresses. We saw the deformations. We will check the stresses too. Therefore, we go here on solids. And we have solid results. Let's check what is displayed currently. We can activate here sigma z, and you can see the contact pressure below the slab also in here. Yeah, we can activate the lines so it can be better seen, like this. And what we can do too is now we can also check the differences to initial state. For example, we have then the stresses in this stage from live load. So this is what comes from live load. Or yeah, you can go through the stages and check for each stage and load combination for that stage how the sigma z is changing. Yeah, this now is the right one. We can look from the top. This is from activation of the dead load, and yeah, you can go through all these and see them. Then we have the principal stresses. Of course, we can also check them. We can, if we go here, no, I don't want to see results now. We go here and we can see the solids. We can also say that we want to see results in the top solid, as maybe we are now interested in, because it's the solid where the most changing occurs at the beginning, and we can change here in this part of the navigator. You can select what shall be displayed, and here at the bottom you can change how it shall be displayed, and we can also use the isobands for solids. And yeah, we can see this here. We can go to the sigma z stresses. Can see how it develops in the soil. Yeah, okay. Then what I can show too is the result diagram. We have here a calculation diagram, sorry. We have calculation diagram. We can go on edit. And here you can define diagrams for specific points, for specific loads, for specific values that you're interested in. And I did prepare an example. We have here, you can select which diagram type you want to see, and we have basic, which is for one combination or for one load. Yeah, we have group, where you can put different diagrams together, and we have the chained analysis diagram, which we can use for construction stages. For example, I have now here, I did start with the final combination for construction stage 9, and I have all the results displayed up to the initial state, the self-weight of solid stage, the construction stage 1. And what we see here is the global deformations, OZ, along the internal force N of that column here. I can show you which node we saw the results for. It's for this column. So we see a load displacement curve in this node where the footing is placed at. And we have here the option to see the diagram more in detail, and you can also activate some intermediate results. And you also have the table, and you can export these values, these results, and you can use it for further things you want to do with these results. Okay, this as example, and it is of course also possible to print it to the printout report. Yeah, okay, we can do it. Okay, then that's it. This is it, what I wanted to show for this model. Maybe we can, as final view, see some results again. Yeah, that's it, what I wanted to show for this main model. Now I would like to go to the next point of that webinar. We will shortly have a look on the triaxial test. Therefore, I open another RFEM file. We have this triaxial test, and all of the models you see today, and also the presentation, they will be provided on the web page of this webinar, so you can download it from there and you can use it. And this triaxial test can be used to calibrate your material input. You give your material values, and you do calculate for your material with these settings the triaxial test. And if you then have from laboratory tests, from triaxial tests, the result from your, let's say, real soil, then you compare the triaxial test results from the laboratory and here from this calculation, and you can eventually change the values a bit up to you have the most good up to you reach that these curves fit well together. Then you know that your material input is able to, with the material model, to represent your soil quite good. So I shortly want to show it. We have here also we have the material and we have the construction stages used. So we have again in the first stage the model prepared and we have the material linearized. In the next construction stage, the material's nonlinearity is activated. We can have a look at this here too. Here you can see we have material linearized and in this stage it is activated. Then in the next stage we have this isotropic load as it was done in the triaxial test, and then we start to load the sample. Here it is displacement controlled, so we will assign 20 millimeters movement in this line support, and after that unloading will occur and then reloading, and then this is calculated, and I can show you now in the calculation diagram. It's prepared for this example. Then you receive for your sample a load displacement curve or stress-strain relation, and yeah, you have here the values of this curve, and you can also check it in detail. You have here the isotropic loading, then you have the first loading, then we have unloading and reloading and further loading, and we have a last unloading, and then this example is stopped. Yeah, and with these values or these curves you can use to compare them with the tests from laboratory and put them into good agreement, let's say. Can show as an example. You have tests from the laboratory, you put your curves and you can try to bring them as good together as possible, and then you know that your input values are fine. So this is how you can use the triaxial test here. Okay, then this is it for now for the webinar. As short prospect on the developments that are going on for geotechnical analysis add-on, we can say that we are there's currently an approach for the calculation of the surface supports according to Pasternak in progress, and a big topic is also the pile foundations. We have the pile foundations in work, and it will be one of the next steps that it will be provided. And we have also started the development for a next material model. The chem clay model is in progress. Yeah, that's it for now. Yeah, then I finished the topics I wanted to speak about with you today. Yeah, I would give the word back to you, Andreas. We can go back to the slide. That's it. Yeah, Andreas, you can take over the word again. Thank you very much for your participation, and see you.
Thank you, Juliane, for this nice presentation. An additional hint from my side, you can book your free online appointment, such as a product demonstration for one of our products, RFEM, RSTAB, our wind, our section, or yeah, you can see our add-ons in a product demonstration. Just click on that link at the bottom or you can scan the QR code and then you will contact our sales team. Okay, that should be also all from my side. Thank you for your attention. Thanks to Juliane for this presentation. Thanks to Alexander for answering the questions. I wish all a nice rest of the day. Bye bye.